3.3 Properties of Logarithms. Again, how do you solve a log normally? If I have log base A of B is equal to C, how do I change it from logarithmic form to exponential form? A to the C is equal to B. All right, so that's still how we solve logs when we can do that. All right, however, sometimes it doesn't work out nicely. All right, for instance, in part A, you got log base 4 of 25. And so if I were to solve that by exponential way, that would be 4 to the power of C equals 25. Do you know what 4 to the power of something equals 25? You don't know that. So yes, that's still working, but sometimes we need what's called the change of base formula. So this is what you do. So now you have, if you have log base A of x, you do log of x over log of A. All right. It doesn't matter what these bases are anymore. So you can do a base 10 system with your calculator. You do the log of over the log of the base. Or you can do the natural log of the of over the natural log of the base. So let's work with this first one. I have log base 4 of 25. Yes, this is really 4 to the power of C is equal to 25, but I can't do that in my head. Maybe you guys can, I just can't. All right, so you do the change of base formula. So you do log of 25 over log of 4. And now we put that into our handy dandy calculator. What do we get? 2.3219. All right, let's do this next one. I have log base 2 of 12. All right, again, I'd try to solve this my other way. I'd do 2 to the power of C is equal to 12. Do you know what 2 to the power of something gives you 12? No. So we do the change of base. So now we have log of 12 over log of 2. All right. And then I type that into my handy dandy calculator.
I got 3.5849.
3.58. What's after the 9?
6.
So it's a 50. All right, very nice. And the second part, I can show you, you can also use natural logarithms. All right, so we could say it's natural log of 25 over natural log of 4. Guess what happens when we do it with natural logs as well? They're the same. You still get 2.3219. You could also do natural log of 12 over natural log of 2. And guess what you still get? You still get the same. A lot of the times I use natural log because it's one less letter that I have to write. So now we're going to do properties of logs. All right, so on our properties of logarithms, whenever you see multiply, guess what that means? Multiply means addition, okay? And you need to go both ways. Now, again, most often in mathematics, we expand logarithms. We break up big logs into small logs, okay? You guys do that naturally as well, if you think about what I'm saying here. All right, and so normally we break up logs and then we break them up into smaller logs. So if you have division, guess what happens? It's subtraction, and subtraction is division. And then this is the power property. We kind of talked about this yesterday. This when we have a u to the n in this case, this n actually comes out front. All right, and so it would be n log. All right. So anyway, now I want to caution you guys. I want to have a little bit of a warning, caution. If I have a log of two things added or subtracted, you cannot break that up into addition. Okay? Whatever you have in there, it stays in there. For instance, what does this adding actually mean? They're multiplied. This is multiplied. Okay? And this was actually saying it's adding. Okay? All right, so there's a little bit of a warning. All right, let's do a quick little warm up. So we're going to write each logarithm using natural log of 2 and natural log of 3. the first thing I have is natural log of 6. Well, what's the relationship with 2's and 3's to give me 6? 2 times 3, right? So this is the same thing as saying natural log of 2 times 3. Well, I have multiplication going on. So what really is that if I expand my logarithm? This is adding. So now I have natural log of 2 plus natural log of 3. So natural log of 6 is the same thing as saying natural log of 2 plus natural log of 3. All right. Is natural log of 2 plus natural log of 3 natural log of 5? No, because they do what? They multiply. All right, let's look at part B. I have natural log of 2 over natural log of 27. So this is now division. So what do we do with division? So division is really what? Subtraction. So now I end up with natural log of 2 minus natural log of 27. Now, I need to get to a natural log of 3. So what could I change this 27 to? Okay, I don't want plus. Okay, I could do 9 times 3. That would be kind of a start. All right, but I really want to do like 3 to the power of 3. All right. So now if I have natural log of 3 to the power of 3, what could I do with this exponent? I could bring it out front. All right. So then I'd end up with natural log of 2 minus 3 natural log of 3. All right. So now we're going to use, we're going to find the exact value of these without using a calculator. All right. So now we have log base 5 of cube root 5. Cube root is really a power of what? A 1/3. And so what could we actually do with that 1/3? We could bring it out front. So this one's really 1/3 log base 5 of 5. Now, yesterday, what do we know log base 5 of 5 is? 1. We know that's 1. And so we end up with 1/3 times 1, which is 1/3. All right. All right, let's look at part B. I have natural log of e to the 6th minus natural log of e squared. What could we do with these powers? Do what? Bring them to the front. All right. So this is really the same thing as saying 6 natural log of e, and then minus what? 2 natural log of e. And what do we know natural log of e is? What's natural log of e, guys? All right, so natural log of e is 1. So now we end up with 6 times 1, and then minus 2 times 1. So we end up with 4. Okay. All right. This next one, we're going to expand the logarithm. So what are all of these doing? I have log base 4 of 5x cubed y. All of these are doing what? Multiplying. All right, multiplying is really doing what? They're adding. So now I end up with log base 4 of 5. And then what? If they multiply, they really do what? They add. So now I have plus log base 4 of x cubed. And then plus log base 4 of y. There's one more step to get full credit. What would you have to do? The 3 comes out front. All right, so this 3 would actually come out front, and so that would actually be a 3 log base 4 of x, and then I still have my other ones. All right, try the other one. Division is actually what? Subtraction. So then I really have a natural log of square root 3x minus 5, and then minus natural log of 7. All right. There's one more step we can do. What can we do? The square root is a 1/2. So now I have a 1/2 natural log, the quantity of 3x minus 5, and then minus natural log of 7. Can I break this one down anymore? I cannot. All right, I cannot. There's adding or subtracting going on. That was that warning, caution. All right. Now we're going to condense logarithms. Honestly, guys, condensing logarithms isn't that important in mathematics. However, we're going to do it just in case. Usually in mathematics, we expand logarithms. However, every now and then you have to condense. All right, so part A, I have 1/2 log of x plus 3 log of the quantity x plus 1. Well, these little things right here, these 1/2s and these 3s are actually what? They're actually exponents. They're powers. All right, so if I put them back in, now I have log of what? Square root x, and then plus log of x plus 1 cubed. All right. Now, I have addition going on. So if I have addition going on, that's really what? Multiplication. So now I end up with log of square root x times x plus 1 cubed. All right. So I go from multiple logs into a single logarithm. All right. Here we go. So on this one, what do I need to do with this 2? This is a what? That's an exponent. So this is a natural log of the quantity x plus 2 squared. And then I have minus natural log x. Well, this minus thing is really what? Division. So now I have natural log of x plus 2 quantity squared over x. All right. And there's my single logarithm. All right. One thing that I get to see from students that mess things up is they actually don't make it one logarithm. They say natural log of this thing and then divided by natural log of x. That's not right. All right. Make sure it's a single logarithm. All right. This x, or this 1/3 thing, is really a what? That's a power. That's a power. So this is log base 2 of x to the power of 1/3. And then I have plus log base 2 times x plus 1 to the 1/3. All right. And then this addition is really what? Multiplication. So now I end up having log base 2 of x to the 1/3 times log, or x plus 1 to the 1/3. All right. Did anybody else have it a different way? You could have that one different. Yeah. What would you have?
I put log of 2 and then I put parentheses x2 plus x and then to the power of 1/3.
All right. X plus.
Like,
Oh, did you distribute the x?
Yeah, 1x, sorry. Or I guess it would just be x.
Did you distribute it or not?
Yeah, I did.
All right. So you had x squared plus x and then to the power of 1/3. All right. That's okay too. Or you could have actually times x times the quantity x plus 1 all raised to the power of 1/3. If you do that, you just need to be cautious of your parentheses just to make sure you're good. Yes?
Should we say cube root?
Yes, cube root's good too. All right. Yep.
Log 2 cube root of x squared plus x.
So you said log base 2 of cube root of what?
X squared plus x. Sure.
You could even say x times x plus 1, and that would also be a legit response. All right. No 24, 26, or 28. All right. 8 through 82 even. Looks like a lot. It really actually will go quite quickly.